So, good morning, everyone. So, this is day two for Punjab Department of Geology, Punjab University, Chandigarh. Invite value added course come workshop on capacity development and skill enhancement initiative and developing competency in the soft skills. So, today our morning section will be given by Mr. Kiran Dhiman on slope mass rating classification and its system. Uh, Rajkiran Bhaiya is hello.
Yeah. Oh, sorry. Hello,
Yeah,
Akshay.
yeah. I'm just so today's topic is slope mass rating classification, state of art. So he's a Rajkira Bhaiya is a PhD student and currently working as a junior research fellow in Department of Geology, Punjab University. He has done his masters in geology from Punjab University, and his field of study is engineering geology, and he has 4 year plus experience in research and field experience. He has also published two papers in SCI journals, and his future goals is to work as an engineer geologist in tunneling and hydropower sector. So welcome Rajkiran Bhaiya. So over to you. Sir, where your mic is off. Mic.
This is
Yeah.
happening with me. Oh, okay. Sorry. So thank you, Akshay, for the introduction, and thank you all for joining this section. It's a little technical session, but I'll try to be as easy with the topic. So we'll quickly start. Akshay, can you see the screen?
Yes, we can see it.
Okay. Okay. Thank you. So as you all know, the topic is low mass rating classification system. Uh, Before I start this session, I just want to quote this quotation that if you can measure what you are speaking about and express it in numbers, you know something about it. I always, start my session something if I'm presenting rock mass rating or now I'm presenting slow mass rating with this quotation because it is very important to understand that if you are going to express any knowledge, if you have some knowledge and you want to express or classify that knowledge into some numbers, so you should know clearly about that particular topic. So this is the base quotation for our today's presentation, and I will firstly explain what is the engineering geology, because I don't know when I was starting this field, I was curious to know that what is actually engineering geology. So maybe there will be some students who don't know, others may be knowing. So I'll explain that engineering geology is nothing but we all know that engineers, they play with numbers, and we geologists, we are more into the how something is, what are the processes. If let's say if we are looking at a landform, so what were the processes that led to development of that landform, how rivers are working. So we are, if we say stratigraphy, we are studying, so we are logging, so we are observing. So if we combine the engineering point of view and geological point of view, then there is this development of an engineering geology field. It is an applied field and basically a interdisciplinary field. So like yesterday our chairman sir was also focusing on this issue that we should be more into the interdisciplinary field. So this is a very good opportunity that engineering geology actually has a vast you know you can club physics also here, chemistry also, and even biology. So many things are clubbed here. So it is a very good topic to pursue career, I would say. So basically engineering geology, like I have shown here in this slide, that to quantify the geological engineering behavior of structures built in or on rock. So in today's modern world, you are looking at, there are a lot of tunnels are being constructed, dams are being constructed, highways in the mountainous areas being constructed. So you must have asked yourself that you see, I when I my father is a mechanical engineer, or there are some people in my family who are civil engineers also. So I used to think that civil engineers are they are the only people who are working there. But when I started working in this engineering geology field, then I get to know that the initial work, actually the very basic work, is done by the engineering geologist, who goes to the field and see the rock mass, what is the rock there, what type of rock is there. You must have studied in your bachelor's to identify different rocks. So that is the basic thing which we see in the mountainous areas. Okay, after that the civil engineering construction work. So it is actually a collaborative work between engineering geologists and civil engineers. So in engineering geology, basically, uh, I would say in today's if I have to concise all the methods that are being used, so there is a broadly two category. One is conventional methods, and another is the numerical methods. In conventional methods, we consider kinematic methods. I think most of you know about this method. All the BSc, if there are BSc third year or students or master students, they are aware of this method. So in kinematic, we are more interested into what type of failure is possible. Like, we are not interested into how, what are the processes behind that failure, or we can say if we apply something that load, so what will happen. We are not interested into that. We are only interested into the kinematic release of any slow failure, or right. So this is a kinematic method, which is a very basic method that is done in the very preliminary stages. After kinematic, there is empirical method. In empirical method, what happened is that we have a lot of data. For example, if I am talking today about slope mass rating. So slope mass rating is actually an empirical method which was developed over the years, and starting with Manuel Romana, who developed it in 1985, and then there were some modifications over the years. So that this classification system is based upon the observation. Actually, the observation of the Romana, he observed that what are the firstly he observed what are the factors that may be possible, that are actually possible, that are actually responsible for the failure of slopes. So he observed different type of factors around the Spain area. Actually, he worked in the Spain country, and then he classified some major factors and gave the rating system. Like I mentioned in the beginning, that engineering geology is geological in engineering geology, the classification systems works on the basis of ratings, or you can say numbers. If you have to give number to a particular factor, so these empirical methods are basically developed on the basis of this. First, we have to define the factors, and then we have to give the rating to those factors, and then those factors can be used in different types of slopes, and we can check if the slope is stable, partially stable, or unstable. So starting with this, there is a limit equilibrium methods also. So limit equilibrium method is a little advanced version of not version, but it's advanced in a physical sense, I would say, because in limit equilibrium method we are interested into the forces. like I mentioned, in kinematic or empirical, we are not interested in the forces. So in limit equilibrium, we are interested in the forces. Like if there is a force which is driving some movement in the slope, and there are some factors which are resisting the movement. Okay, so limit equilibrium method is basically a ratio of what are the driving factors and what are the resisting factors. So we are, if I have to explain what is a driving force, so there can be weight, like we study in physics also, that in physics we study this problem, no? Triangle, there is a some bar is there lying, and some force F is equal to mg is acting on the bar. So some kind of, you can imagine that, yeah, we can consider all those forces also, but there are other forces also. So that is what is considered in limit equilibrium methods. Probabilistic methods are there, which actually considers the variation in the, what is the variability of the different factors being considered. Let's say, in limit equilibrium, I am considering one factor, that is friction angle. For example, friction angle is actually what is the minimum angle up to which the slope is stable, after which the slope will fall. Okay, so but in a slope this can vary also. So in probability we are more interested into, let's say if we vary the friction angle from 30 degree to 40 degree, so what will happen? The slope will fail, or there will be partial stability, or you know, we are more interested into the probabilities of different type of variables there. So in numerical methods, if I come to numerical methods, so there are broadly continuum methods, discontinuum methods, and hybrid methods, which considers both continuum and discontinuum. This is the, actually this is, there is a very vast explanation to these topics, and today I will not go into this, because this is not the goal. But you can ask me questions about all these methods in department or anywhere, I can, even today you can ask me any question. So I'll quickly start with the empirical methods. And in empirical methods there are many methods, but we are today talking about only slope mass reading. So before I start, I would like to ask you all people, what is a rock mass? So if anybody can answer me, what is rock mass? Okay, so basically, before going into rock mass, I should ask you. See, this is the definition actually which I have taken from some website. So it is actually a correct definition of a rock mass. That when a rock mass is intersected by a sufficiently large number of weakness planes, and it's a long definition, so it is a little confusing for beginners. But I'll break this definition. So all of you know that what is rock. Rock is basically an aggregate of minerals, right? And rock mass is basically when a rock has a lot of discontinuities in it. Discontinuities can be in any form. Okay, like bedding plane is also a discontinuity. If there are joints, so joints are also a discontinuity. Faults are there. So if there is a rock which is intersected by these discontinuity planes, that makes a rock mass. It's a simple definition. So let's say if I ask you this in this slide, is this a rock mass or not? Akshay, can you see? So what do you think about this picture? Is this a rock mass or rock? Yeah. I mean, it's a rock. Obviously, I shouldn't ask you like this. This is a rock. Obviously, this is a rock, but this is a particular type of rock that we have to identify in the field. But there are a lot of discontinuities present, and we are looking at the outcrop scale. So we can say that this is a rock mass because let me show you. See, if you can see, there are joints present in it. I have marked with the yellow line. This is, let's say, this is, I have roughly marked. Let's say this is joint set 1, and in the red mark, this is joint set 2. So there is a proper joint system present here. So like the definition says that if a rock is intersected by discontinuities, that is a rock mass. Okay, so in the outcrop scale we can say this is a rock mass, and we can apply the rock mass classification system to this outcrop. Okay, So the question comes that why do we need these rock mass classification systems? So if I have, like in this slide I'm showing you this rock mass, so you must be interested into the stability, if this slope is stable, or what is the rock mass condition. So you want to give some ratings, yeah, so that the method can be applied to any slope. So I'm considering that, let's say we are in the beginning of these development of these rock mass classification systems. So how these earlier engineering geologists must have thought. So if I will go into the basics, okay. So they must have asked these basic questions like, what are the factors that control the stability of a jointed rock mass? So can anybody answer me that, by looking at this picture, what can be the factors that are affecting this particular rock mass? If you can answer me this question. Yeah, right. Stress is there. Stress will
Rock
be
strength.
there. So sorry.
Rock strength.
Yeah, there is
Strength of
rock strength also. About yeah, this is correct actually, because we are looking at rock. There is a rock present, so you want to see that how hard, or what is the strength of that rock. We do that. For that we do compression test, and other tests are also there. We will not go into that. We will simply say that, yeah, कि कोई चीज कितनी strength है किसी चीज में, है ना. This is one factor. So there are also other factors, because I mentioned in the beginning that there are discontinuity planes. Okay, so discontinuity planes, as we can see that it is like a crack in an object. There is a crack, and the movement can be along that crack, right? So we have to classify that what are the factors which will govern this movement along the planes, right? So this is one of the very important parameter of rock mass classification. So, see, this question has very simple answer, and if I go into this answer, so these factors are like block size and shape. What is the block size? Block size means after the intersection of joints, there will be obviously development of some blocks, है ना? Because of the in 3D, we can see there can be number of joints. So there will be a formation of a block that has a different shape, not necessarily a cubical shape. Okay, so the second I mentioned, what is the shear strength of the weakness planes? Don't get confused with this word shear strength here. You can just imagine that we'll again go into that problem of inclined plane, which we study in class +2. If there is an inclined plane and we are keeping some object there on the plane, and we are rising the angle, and at some time the block will move. So basically, we and also there is a very famous video on this topic, also inclined plane, where you can see that if you increase or decrease the roughness of the plane on which the object is lying. Let's say I pour some oil on the inclined plane, so there will be immediate movement, right? You agree, na? So simply you can say that the shear strength parameter is actually some analogous to that oil thing also. I mean to say that what is the strength of that plane. So in what happens is, in natural world, in these rock slopes there are some discontinuity planes, we already know, because only then we can say this is a rock mass. So discontinuity planes, so we have to characterize what are the factors that govern the shear strength of weakness planes. Right now we get this idea that there will be some important role of this strength of the weakness planes. Okay, so the third factor, as Akshay mentioned, that what is the confining stress. See, the stress can also be in different terms. Like I can say that what is the stress? Stress due to the we call it as a orogenic stress. Like if I am working in Himalaya, so there is a particular direction of stress going on. As we already know that this Eurasian and this plate, Indian plate, there is a collision going on, and there is some kind of a horizontal stress is always there. So when we are working in tunnels or underground cavern we have to construct, so there is some horizontal stress always working. Okay, so but there is one other type of stress that we call as man-made stress or induced stress. let's say in Himalayas we are constructing roads nowadays. So what is happening is that because of the current cutting of the road cut slopes, na, there is some excavation going, and the natural balance of the mountain is disturbed because of the excavation. So in order to balance that equilibrium, there will be some movement in the blocks, as we can imagine, because there is a the equilibrium is disturbed because of the excavation. So that is also considered in the stress factor. So basically there is a fourth factor, external factors. External factor simply means that you can say what is there was some natural slope, and external factors like earthquake can be there, and some groundwater or drainage is there. Rainfall can also be act as an external factor. So, see, this question was asked. We are imagining that this is the first question that these people must have asked, in the beginning, to develop some kind of a basic understanding that what are the factors that are governing the stability of this jointed rock mass. Now we can go further into every factor. For example, what define the size of rock blocks in a jointed rock mass? If I have to ask this question, so can anybody answer me this question? Okay, don't worry. So, see, this is a very simple question because we have seen in the earlier figure that there is a rock mass which is intersected by different discontinuity planes. So, discontinuity planes, let's say they are joints. So we all have studied that there is a joint system, which means that there is a particular joint set which is occurring again and again on a particular distance. So we call that spacing between the different joints. Obviously, if there is a spacing between different joints if in 3D there will be more than two joints obviously in the slope. So we can define a rock block on the basis of the what is the spacing between the joints. Okay, so in order to answer this question, they have mentioned what are the number of joints, total number of joints, and what is the spacing between the joints. That will govern the block size. Okay, so what controls the strength of joints in a jointed rock mass? So this is a very important question. As I have mentioned, that discontinuities plays a very important role in the classification of a rock mass. So to answer this question, uh, these people have come up with these major 5 points, that what is the roughness, like I have mentioned with already this with this example of inclined plane. So if there is a more roughness, obviously there will be hindrance to the movement, so the blocks will not move. है ना? Planarity, if there is the planarity is something like how if there are no disparate asperities, the joint plane is smooth, these type of categories are involved in this uh, planarity parameter. And there is joint surface alteration. Okay, so we can think of this like there is a fresh joint surface where no rainfall or groundwater is percolated, so there will be no weathering, the fresh will be there. Or if it is weathered, so weathered joint surface will have low strength to movement, right? So what is joint infilling? As we can see that in joints there is sometimes space in between in a joint. We call it also joint separation or joint aperture, we call it. So but sometimes the joint aperture is very tight, there is no aperture. Okay, sometimes there are some kind of fillings inside the joint aperture. So we have to consider all these parameters to define the strength of joints. The next question is what are the stress controls on a jointed rock slope? So basically, these four questions are actually those which we asked in the beginning. That what will be the major factors affecting the rock mass? To answer this question, I have already mentioned what is the in situ stress. So what is the in situ stress means the local stress that is there. For example, in Himalayas or in any mountainous orogeny, we can see there is a continuous collision going on. So there will be some kind of in situ stress. We have to consider that. Induced stress I already mentioned, like for example due to excavation. Water pressure is there, and dynamic stress due to earthquake or other activities there, because if there is earthquake, so there will be some kind of shaking, and due to shaking there the blocks will move from their original position. Okay, so these are factors which are considered in the stress controls. So now we come to this point that how rock mass classification works. See, why I'm explaining all these rock mass classification parameter is because today we are going to talk about slope mass rating. And in slope mass rating, we are taking rock mass rating as a base. So rock mass rating is actually a rock mass classification system, right? So we have to understand that what are the major factors that govern the RMR system. So that is why I am explaining this in briefly. So rock mass classification system, as I mentioned in the beginning, that it puts a number to the quality of the rock mass. And now, if I have to ask you what is the how to classify the quality of rock mass, then we have discussed these 4 5 factors, which are the major factors. Okay, so these govern the quality of the rock mass. So rock mass rating is actually a rock mass classification system which was developed in 1973 by a scientist called Benyovsky, and over the years it got modified, and 1979 it got modified, 1989. So what are the major factors that this classification system has considered? Earlier we studied that what could be the major factors that can govern a rock mass, quality of rock mass. But there are different types of rock mass classification systems that I will show briefly in one slide. But if we talk about only rock mass rating, it has its own 5 or 6 parameters. Okay, one is uniaxial compressive strength of the rock. Second is rock quality designation. Third is spacing of discontinuities. Fourth is condition of discontinuities. Fifth is groundwater condition, and sixth is joint orientation. So these are the 6 major factors, and I would say that earlier this rock mass rating actually was developed for tunnels, but later it was also, as we are studying today's SMR. So in SMR, Romana have used RMR as a base, and he has used some kinematic actually methods, and also given some weightage to the kinematic methods, so that he can arise at some weighting system criteria of classification, into classes. I will explain that in detail. So a rock mass rating, I will not go into detail of this, and I will just show you this slide, this link. This is where I have already last, I think in 2020, we had a session on this RMR. So it is available on YouTube with our department AAPG link. So you can watch this and understand, if you want to understand what is RMR and how these factors govern it. Today, okay, now I will briefly give you some idea about the rock mass classification systems. Today, we have a different number of rock mass classification systems. Okay, we have RMR. Actually, I would say it was the actually it started with RMR. Actually, these classification systems, and then there was a Q system, which were developed by Barton and others, and it is majorly used in the tunnels. And then came SMR, which is using RMR as a base. I will explain that in detail. So today we are more interested in the SMR only. With time there were major modifications of SMR. So there was Chinese slope mass rating, which was given in 1995, and then continuous slope mass rating in 2007 by Thomas and others. And there is a new slope mass rating, which was given by our Indian authors, Singh et al. In 2010. And then there is fuzzy slope mass rating, which was given in 2011, and graphical slope mass rating. So there is a broad explanation to all these 5 methods, but it will take 1 hour to each, to if I have to explain all these modifications. But I will today go into the basic SMR and some modification, that is continuous slope mass rating, because these are majorly used, widely applied and majorly used over in across the continents. So now I will go into there is one more classification called SSPC, slope stability probability classification. There is a very widely used GSI classification system called geological strength index, and there is hazard index 2010, it was developed by Pantalids. And in 2014, there was a new classification called rock mass quality rating. They are all rock mass classification systems. Okay. In 2007, there was some modified version of Q system, which is called as Q slope. So Q slope is used for slopes, but Q system is used for tunnels. See, there are many classification systems. So it is up to the investigator that what is his observation and where he is working. If he's working in tunnels, if he's working in slopes, if he's working in the mining environment. So there are some mining classification systems also. So accordingly he has to choose a classification system. And of course there are many limitations to different classification systems. uh, as I would say that today I am explaining SMR, but since I am working in the past for the past 2 years in this using this system, so I get to know a lot of things. Like I know that there are many limitations to SMR also. So there are many limitations and you can improve them, develop your own classification system also. If you have observations, like Romana had observations about different slopes behaving similar type of behaving differently in different type of condition. So he had some idea and he developed the classification system using those a few factors which I have already mentioned, the major factors. So this is a brief idea about the different classification system, and if you have any questions up to this, you can ask me, because otherwise I will continually speaking. And if because this is for you all, and if you have any question, you can ask me. I think it is either very much clear to all or. Uh, don't worry, this is a discussion session actually, and you can ask even any silly question, because I know I was also at your stage once. So don't worry about it. So I know, okay, so I think I should go further, and you can ask later, okay, after the presentation. So we are up to this. Okay, so briefly I will give some, what is the use of SMR. So you all must be thinking that why I'm talking about this SMR classification system. See, SMR classification system was developed in 1985, and for the past now it is more than 30 years. But I'm showing you the review of up to the 2015 year. So Romana and others, they have mentioned in their paper in 2015 that SMR was globally used across the continents. And if you can see in this figure, that in this world map, all those countries which are dark black gray color, dark gray color, like India, China, there are some European countries here, Spain, America, no? These all countries actually they have used SMR, as well as they have included SMR in their course. Technical regulation means they have included that in their course also. For example, you all in your bachelor BSc third year, you must have studied this classification system. So nowadays it is very widely used across the continents, and it has a very good output in the preliminary stages. Actually, I would say this classification system is used in the very beginning of any project. Let's say if we have to develop some highway, so this classification system will be used in the very very early stages, so that we can get an idea that these are the slopes. Let's say we are working the 100-kilometer stretch, and every 10 kilometer we are working on more than 10 or 20 slopes. So there will be some slopes which are stable, which are partially stable. So you will get an idea that how you can think of it in a economical perspective also. Let's say if there is a contractor who want to build some road, so he can use SMR classification system there in the preliminary stages. So he will get an idea that okay, there are 100 slopes, and out of which 50 slopes are partially stable, 50 and other 20 are not stable, but some 10 slopes are very unstable. So he can use SMR as a index to quantify that how much money he has to invest in that, right? So this is how you can imagine SMR. There are many dimensions to it, not just as an engineering geologist you are doing your hello. Yes. So yeah,
Kiran,
Akshay, hello.
Rajkiran,
Yes,
Rajkiran, this
yes sir,
is
yes
Ravi.
sir. Right sir, right sir,
Actually,
good
I
morning
wanted
sir.
to, good morning. I just wanted to add something that
Right sir,
you
right,
were
yes sir, you
saying
can add.
that you were saying that in the contractors they use SMR to quantify the means how many endangered slopes are there in their construction path.
Yeah,
But
yes, sir.
in India,
Yes, sir.
there is a very big problem that none of the national highways have a
Right, sir.
DPR submitted, a DPR having a geology chapter.
Right, sir. I know, sir. I know, sir. This is a problem. Okay, sir.
Only the
So,
hydro projects are having a geology chapter, and they discuss the geology very extensively. But
right, sir.
none of the national highway projects are considering the geology chapter.
Yes, sir. This is actually a problem. Maybe
Once
the
there is a
reason for
mishap
this
or
is
there is some problem,
right.
yeah, this is the reason only the highways are failing.
Right, sir. बिल्कुल, बिल्कुल, sir. बिल्कुल. Yes, sir.
और जस्ट अभी कल ही एक हिमाचल प्रदेश हाई कोर्ट में एक पीआईएल हुआ है
Okay,
and
sir.
means geological stakeholders they will be contesting against the government कि आप जियोलॉजी चैप्टर को भी इंक्लूड कराइए और जियोलॉजिकल कंसर्न्स को भी करवाइए अब
That is great, sir. That is great. Actually, ये होना चाहिए. बिल्कुल सही
बिल्कुल
बात है, sir. ये तो. But the problem, I think, sir, there is because of the funding issues. I think this is.
नो
I
नो
don't
नो
know
नो नो एक्चुअली
why they are.
एक्चुअली प्रॉब्लम इज दैट ना कि जैसे कि आप रख लीजिए कि 1,000 करोड़ का एक ठेका निकलता है तो दे
Mhm.
स्टार्ट बिडिंग जो सबसे लोएस्ट
Right.
बिडर जो होता है उसको मिलता है ये एंड द लोएस्ट बिडर बिड्स जो बेस लेवल जो उनका कट ऑफ लेवल जो कंपनी जो रखती है मतलब कि जैसे गवर्नमेंट ने रखा 1,000 करोड़ का ठेका है तो वो उससे भी कम रख देते हैं ये लोग ताकि
Okay.
इनको L1 मिल जाए और
Mm-hmm.
उस पूरे कॉन्ट्रैक्ट डिटेल्स में ये लोग ये नहीं डालते हैं कि मेरे को स्लोप स्टेबलाइजेशन में इतना खर्चा आएगा
Oh,
और
अच्छा.
क्योंकि उनके पास कोई क्वांटिफिकेशन ही नहीं रहता है कि हमने
Right.
एसएमआर तो उनके लिए बहुत बड़ी बात हो जाएगी
Right, sir. Right, sir. Right, sir. ये एक लिमिटेशन है,
तो
सर.
इसीलिए मेरे को ये कहना है कि इंजीनियरिंग जियोलॉजी का बहुत आने वाला फ्यूचर बहुत ब्राइट है
राइट,
बस
सर.
खाली इसको एक लेजिस्लेटिव ये देना है मतलब ड्रेस
हाँ.
पहनानी है
एक बार ये
इतना
ऑफिशियली उसमें आ जाए.
अब इतना ब्राइट है ना कि अगला 50 ईयर्स सिर्फ और सिर्फ इंजीनियरिंग जियोलॉजी चलेगा
Okay, Ravi sir. Actually, for all those who are listening, I would like to mention that Ravi sir is actually a geologist in Geological Survey of India for the past, I think, sir, if I'm not wrong, you are for 10 years. I think your
या
age.
10 years 2012
Yeah. So in the end of this session, I would request all of you to ask some questions from sir. Also, I mean, many questions you can ask if sir will be there at the end. Okay, sir. I think if it's not a problem with you.
no I'll be there
Okay. Thank you, sir. Thank you.
okay you continue please thank you
Okay, sir. Okay. So I just wanted to, make you all aware that SMR is globally used and across the continents it's being applied. So yeah, there is this problem that in India it is not involved in the beginning in the highways actually. So sir has mentioned correctly, and the government should take it into account. So moving further, uh, I will give you a brief idea about this classification system. What is it and how it works? See, SMR was developed in 1985, and it uses its four correction factors which are being applied on the SMR RMR. So why I was explaining you all those major factors in RMR in the beginning, the reason was that because RMR is directly used as a base, as you can see in the equation one. RMR B, don't get confused with this B. RMR B means basic rock mass rating. It means that, as I have shown you in the earlier slide, RMR had six parameters. The sixth parameter was orientation of the joints, but that was you developed for the tunnels only. But Romana, what he did is that he developed SMR for slopes. So he had to use some different, kinematic adjustment factors, which I am going to discuss. So if we neglect the sixth parameter of RMR, that is joint orientation, and only consider the earlier five parameters, that is called as rock mass rating, basic rock mass rating. So in basic rock mass rating, we add this F1, F2, F3, and F4. These are four factors. These are added to RMR, and then we get a value of SMR out of 0 and 100. So, if you ask me what is F1, F2, and F3, these are, you can simply imagine that these are the, like I mentioned, these are the kinematic parameter of release. If there is a joint plane, which is, which has a dip direction in the direction of slope. if you see the figure, this figure in the right hand side, there is this joint shown in the blue color. You can see my mouse, Akshay, my pointer. Can you see? Okay, okay, thank you. So see this sky blue color, you can see here, this is actually a discontinuity or joint plane. But we can clearly see that it is not properly, it does not have a same strike direction as that of the slope, because this slope has a strike direction this here, as you can see this black line, na? And this discontinuity has a strike direction here, this. And in the discontinuity strike and the slope strike, there is some angle called A. Okay, so it is very simple to understand here. Let's say there is a slope and there is a joint plane which is dipping in the direction of the slope. The same direction in the slope is also dipping. So and the strike has some angle. There is a difference in the strike direction of slope and discontinuity. So you can ask this question to yourself that how much effect will be there on the kinematic release of these planes. This is a question which actually Romana asked, that we, because we already know in kinematic analysis that we which we do, that if there will be a planar failure, there will be a wedge failure or direct toppling. Yeah, we know that, but we just know it that yeah, there is some joint data, we plot it in the stereonet and we say that there is a planar failure. But why is there need to develop SMR? Because SMR will tell you that how much possibility is there of the planar failure, how much possibility of there is wedge failure, how much possibility of there is the toppling failure. So in I would like to mention also that in SMR there is only consideration of flexural toppling. Direct toppling is not considered here. Okay, so this is actually the main point, that you already know what is kinematic analysis, but you want to give some weightage, that let's say if there is the angle A varies between 0 to 10 degree between slope and discontinuity strike, so how much it will affect. So this is what Romana thought, and he did some work in Spain. He observed some slopes and he saw that if the A angle varies between 0 to 10, there is the maximum chances of failure. If A is, let's say it is like, A is not like this, it is like 90-degree, so you can immediately see, yeah, the joint will be stuck in the block, in the rock mass, there will be no kinematic release there. So in order to quantitatively give some weightage to these indexes, these values, like A is actually a strike parallelism, so he has developed these factors called F1, F2, F3, and there is F4 also, which I will show you further. First we will go into F4, when F1 is basically the strike parallelism factor. Okay, so here I am actually showing these are actually the continuous functions. I should show you this slide actually. Wait. Okay, this is the slide. You can see this parameter in this table. You can see this parameter A here, and if I have to read this table and get the value of F1, I have to see that what is the value of A. For example, in this very favorable condition, okay, that the slope is stable, the F1, the value of A is greater than 30-degree. It means that your the value of F1 lies in 0.15. You will write this value in your notebook, and you will let's say if the A value is less than 5-degree, then you will write one value there. Similarly, we have to check for F2 and F3. Okay, so F2 is basically what is the dip amount of the joint. Here you can see beta J. It is the dip amount of the joint. Let's say if this joint is dipping at a 0-degree angle, there is no dip. So this horizontal plane, this beta J will be like this plane, horizontal. Okay. And the third parameter F3, and in I would mention that in this beta F2 parameter, the role of actually angle of internal friction is considered actually here. That let's say you have done some tests on the rock sample and the internal friction angle is 30-degree. Okay, and your joint is dipping less than 30-degree, let's say 20-degree. So basically you are getting an idea that this joint has very less possibility of movement, because it has not crossed the angle of internal friction. Like I have mentioned, if you remember in the beginning of how that inclined plane angle. Okay, that if that particular block will move at a particular angle, that we call as an internal friction angle. So Romana also did this, but he did is that he observed different joint planes, and accordingly he has classified in this table that if F2 is less than 20-degree here, then you have to use value 0.15. If it's 20 to 30, similarly it goes to greater than 45-degree. Okay, the last parameter that he considered was the, we call it as a daylight envelope. डेलाइटिंग कितनी है जॉइंट्स में. डेलाइटिंग में कंफ्यूज नहीं होना है. डेलाइटिंग सिंपल ये होता है कि जो आपके जॉइंट्स हैं, लेट्स से दिस इज अ जॉइंट, इट इज डिपिंग less than the slope, so it is a daylighting joint. Okay, why it is daylighting? Because you can imagine that the joint has a dip angle of 40 degree, and slope has a dip amount of 80 degree. So the joint will move if there is some kind of a movement, or the shear strength is decreased because of some external factors, because their kinematic release is very easy because joint is lying above the slope. Okay. Similarly, if say joint is more than 70 degree and your slope is like 40 degree, so your joint is going inside the slope, so there will be no planar type of movements, or we can say we will also see wedge type of movement. So but you can also imagine that if the joint is 90 degree dipping inside the slope, so there will be the development of this condition of flexural toppling there. Okay, so we have to consider all these things also. So the F3 parameter is actually basically concerned with the relationship between joint dip and the slope dip. What is the relationship? So for example, here you can see that this C parameter is there for planar. P means planar. You have to check beta j minus beta s. Matlab, don't confuse with these. Because I will explain it sometime later. But today you just have to understand that this is just we are going to understand the relationship between joint dip and slope dip. If the joint is above the slope, simply imagine the joint, there is a possibility it will move. If it is inside the slope, there is no possibility it will move further in case of the planar or wedge failure. Okay, but yeah, there will be a development of toppling type of condition if the joint is dipping inside the slope. That has to be understood, but that is considered in SMR also. So there is one excavation method factor F4. It was considered that let's say if there is natural slope, which there is no excavation happening, the slope is normally lying there for the thousands of years. Okay, so you have to give 15 rating as per the Romana conditions. So if there is a blasting or mechanical excavation, you have to give 0 rating. Similarly, there are different numbers given to deficient blasting, smooth blasting, pre-splitting. These are values which should be added into this equation here, F4. You have to add these values here, and you have to collect all the F1, F2, and F3 using this table which was provided. You have to carry this in the field and you can give a rating. So this was in the beginning where Romana developed this classification system. So imagine it that he was trying to capture the what at what value of strike parallelism, or at what value of joint dip angle, or at what value of the daylight relationship between joint and slope there is the maximum chances of planar, wedge, or either toppling failure. So he observed many slopes, and he has published in his paper that if there is this type of condition, you have to give there was a failure. So let's say very favorable condition is here on this side. We call it as a class 1. Class 1 means the SMR value lies between 80 to 100. I will show you that slide also in the later. Okay, so this is class 1, and if I go to very unfavorable, it means that the slope has very much chances of planar, wedge, or toppling failure. Okay, so I hope this is clear up to this point, and I will now explain that how we go to field and how we collect this SMR. How we first we have to collect the joint data and then apply these factors. So I will quickly start. First, we like I mentioned, we already know what is the RMR value. Let's say we know that the RMR for this given slope, it is 75 in the field. We already know this value. Okay, considering all the major factors which I mentioned earlier. So now I want to check that what is the kinematic possibility of planar wedge or toppling failure. So I will first I have to mark the joints j0, j1, है ना, slope का data, dip direction, dip amount. We have to collect all the data. Now we have to apply the adjustment factors F1, F2, and F3, which are calculated. Okay, desk study we have to do, which I forgot to mention one important thing here, that Romana developed this system, which if you can understand that this is a discrete type of classification system. Let's say because according to Romana, between 20 to 30 there is a fixed value of 0.4. Okay, and between 10 to 20 there is a fixed value of 0.7. So we call this as a discrete system. But what happened, Romana has given these functions, math continuous function, we call them f1, f2, f3. And okay, this f3 is for planar wedge, this f3 is for toppling failure. So these continuous functions can be used if you want to remove this discrete nature and make the make a unique value to the every value of a, beta j, and the relationship between beta j and beta, that is factor f3. So he gave these continuous functions, and accordingly you can get a unique value. Otherwise, what happened, like I have shown in this slide, you will get a fixed value. Greater than 30 degree means you have to use just one value, 0.15. But there was some problem with the let's say there is a slope which is having there is some boundary, there was some boundary problem because of this condition, because there will be some data which is lying in between here in these boundaries. So in order to remove this boundary condition, there is this continuous function being developed. Okay, so we were here. First we have to develop the, we have to calculate joint data, and then we have to apply f1, f2, and f3 as you mentioned earlier. We can I have shown in this figure here planar, wedge, and toppling. Okay, so you can see that we can calculate SMR value for planar, wedge, and toppling individually, and then we use Romana's table for classification of the SMR class. Okay, so this is just an example how it was used. So what happened is that I have developed some charts where we can use where we don't need to use the adjustment factor. What I meant is that f1, f2, and f3 factors are already incorporated in the charts, because otherwise what was happening was you had to collect a lot of data in the field and get the desk study where you have to use Excel sheets and apply those continuous functions. But with the advent of these charts, you can use in the field. You can get the value of SMR in the field, like we were talking about the highways problem. So you can immediately give the SMR value in the field itself. You just collect the joints data and then plot in the charts which are provided, and then you get the SMR class. So because of this, the thought came to my mind, and I have developed the SMR charts. We have used the continuous functions. So I will quickly explain you a little bit about the charts. We already know that RMR basic and F4 value is taken as a constant parameter in the equation 1, if you remember. And F1, F2, and F3 variable, these are the variables, three variables, F1, F2, and F3. So what happened is that we can vary these values f1, f2, and f3 from let's we call it as a simulation. Simulation is nothing. Simulation is basically you want to see the possibility that what if the value is 0.1, then what will be the result, what if the value is 0.2, what will be the result, what is the 0.3, and so on. Okay, so I have done the simulation for all the possible values that can exist in the F1, F2, and F3 parameter, and directly add it to the RMR and F4. Since RMR and F4 is a constant parameter, so there will be no change in the graphical contours of SMR. It is a little difficult to understand here, but you just for the timing you understand that if there is a constant RMR and F4, the drop in the SMR will be constant, and the contours of SMR which will be developed, they will be constant. So what happened is that these are the, I have developed this number of 7,29,000 of combinations between different orientations of the joint and slope geometries. Okay, for this I have used MATLAB. Either we have used also Python for this. So these are the programming languages. What is the help of these languages is that you can in the fraction of seconds you can develop so many values. That is just otherwise you had to calculate. You will be amazed that what happened is during 2019 I was not aware of these languages. So I would request you all to study and develop this skill also to use MATLAB or Python, because then I learned this language and I was able to generate all these values using some coding there. Otherwise we had to use Excel sheet and vary individually every value and then calculate the SMR value. So this is a little bit difficult to understand here if you look at this figure, but I just clearly want to see you at this figure, slope figure. Here you can see that the slope face is, this is the slope face in the green color, and this is the joint plane here. Okay, you can imagine it like this: joint plane and slope, they both have same strike direction, है ना, अभी तो same है. So but we want to calculate the different possibilities for calculating the SMR value. So I have varied these values. Joint plane I have one by one I have varied from 0 degree to 90 degree. Okay. Similarly, I have varied the plane dip also, joint dip from 0 degree to 90 degree, as here mentioned. And for every variation, I was checking the SMR value. Okay. So there is this flow chart basically, and right now we have developed this tool also. What happened is that in the charts which I have developed, they were given for fixed values, like for 35-degree slope dip, for 40-degree slope dip, and 45-degree at a 5-degree interval up to 90 degree, because there can be, angle can be up to 90 degree. But what happened is that because of this tool, we can get the slope dip value. Like if you want to you can see in the field if there is a slope of 47 degree or 48 degree, so you want to see what will be the SMR chart for that slope dip. So you can use this tool, and you can just put the value of slope dip, beta s slope dip, and you will immediately get the chart for planar wedge or either toppling failure. So this is a tool which we have developed, and if there is chesscon coming also, and I will be presenting this in the department, that how I have developed this. So you can ask me any questions there also, okay, during the chesscon. So this is a new development, because earlier we had only 12 charts. Now people can use this tool. It is an open source tool, and they can develop any chart. Okay. So I will show you how these charts are developed. So this is the interface of the tool which we have developed, and you can see that deep amount of slope, you just have to put the value here. For example, I have used 90 degree, and you click on the planar wedge, and you can generate the SMR chart for planar wedge. And if you want toppling failure, you can generate the chart for toppling. Why planar and wedge is combined in the single? Because the factors that govern planar and wedge, they are similar actually. Okay. Next is, this is the result for planar and wedge failure case. So, in the beginning, I showed you how earlier people used to collect SMR. They used to collect joint data and then do desk study and then get F1, F2, F3 and multiply and then get the SMR. But using these charts, let's say your slope is dipping at 30 degree, and you get the strike parallelism value A in the field, and you put the joint dip value in the y-axis. So if you will immediately get the class value because of these contours. How these contours are used, that is also explained in the later. I will show you. Similarly, for 90 degree case, this is for toppling failure. I have shown you here two charts only, 30 degree and 90 degree. So I will show you how to use these SMR charts. First, you go to the field, you take the slope phase data, that is dip direction and dip amount. Okay. And you take the joints data. Let's say you have J0, J1 and J2, three joints present. You will collect the dip direction, you will collect the dip amount. You will collect, then you will, in the field itself, you can just calculate the strike parallelism between the two joints, your joint and slope phase. In this case, there is a slope is dip directing as 050. It means 50 degree from the north. Okay. And joint at is a 40 degree. So there will be angle of 10 degree. So strike parallelism is 10 degree. Similarly, in toppling failure, you can do this thing. Just there is a difference in the calculation part of F1, F2, and these A value. How A value is calculated for toppling is little bit different, and for planar and wedge, it is similar. Okay, for wedge failure, if you are good at doing stereonet, this is the only limitation of these charts, that you have to use the stereonet here in the field. But I think as a geologist, it is very easy for us to use the stereonet in the field and just draw the planes. And why we are drawing planes is that because we want to collect the value of intersections, J0, J1, J0, J2, and what are the trend and plunge values of these values, because then we can get the strike parallelism value out of the trend and dip direction of slope. Okay, so once we get these values, these A value and beta j or beta I means the plunge of the intersection line. This is the stereonet I have shown, that how we can draw it. Then what happens is that, let's say you get a slope of dip 80 degree in the field, and you, let's say you have RMR 100. So my these charts, how I have developed is that every chart, if RMR is 100, so these contours will be drawn at an interval of 5 degree. So these will be 95, 90, 85, 80. Okay, why 5 degree interval? Because we are more interested into the class, not the SMR value. Okay, and if RMR value is, let's say, 80, so these charts are same, the contours will be same, there is no change contour, because we already shown you in the beginning that RMR and F4 factors are constant variables. They don't affect the contouring. Okay, so if RMR is 80, then the contours will be drawn at the value of 75. Here will be 70, and similarly. So we already know what is the class value between 85 and 90, 80 to 90. We already know. So what we have done is, for planar failure case, I have plotted the J node data. So J node is lying between 60 to 70 or 60 to 65. So I immediately get the idea of class here. If it is lying between 60 and 70, it suggests SMR class 2. Okay, as per the Romana's table, which I will show you in the later. Similarly, I have done it for the wedge failure case. There were two intersections which were less than, which have strike parallelism less than 90 degree, and this is the plunge value of the intersection line. So I have plotted these two values here. And I can see that the one intersection is very favorable. There is no failure because our SMR is very high. The second is lying between 60 to 65. So there is some probability of failure along this wedge failure. Okay. Similarly, I have done this for toppling failure. There were two intersections. One is lying between 85 to 90 SMR. Another is lying beyond the 95 value. So clearly the toppling possibility is very less in this slope. And we can see immediately in the field that, for if I have to just tell uh, what is the class value, or how stable the slope is that we have considered in this dummy slope, we can see that SMR lies between planar lies between 60 to 70, that is class 2, because this is the Romana's table here. And 60 to 70 means class 2. The description is good, the slope is stable, stability is stable, and there can be failure of some blocks. And if SMR for wedge is lying between 60 to 70 for J0 J2 intersection, it is also lying between the class 2. Okay, so there can be some wedge failures along, some block failure or wedge failures along this particular intersection. For toppling, there is class 1. Class 1 means there is completely stability and there is no toppling failure in this particular slope. So you can see that using the charts, we can immediately tell the field person that this is the SMR value and these are the stability measures. So these charts will, these are increasing the work efficiency, or they are more efficient. And the preliminary work is actually, it is increased, the efficiency is increased of any project because of these charts. So this is what SMR is about, and I have shown you the discrete nature also, some continuous functions also, and now this little bit of my contribution in this SMR charts also. So if you have any questions up to this, you can ask me, and I hope you all were able to understand this SMR classification system. You can ask me any questions if you have, or you can just ask me any silly question even if you have, because this is a discussion part here. And it was little technical, but still, if you have any question, you can ask me further in the chesscon. I will be presenting this SMR there also. I think it is not clear, or it was very much clear. Yeah, 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 you should ask. Mm-hmm. Yeah, yeah, yeah. You are saying these formulas, Akshay? Okay, so you're interested in how I developed this code. See, there is no simple answer to this question, but I would say that once you start programming, then it becomes easy. For me, it was a little easy, I would say, because I have already worked in MATLAB since 2018. I am working in MATLAB. I know basics of that. For Python, I was little worried in the beginning, but uh, the one student Manik, he has helped me in Python also programming, because he was quite good in Python. So he helped me with Python, and I think it is easy for you all to learn. You have to just enroll for any course. Like I'm also doing one course. There is an app called Coursera. You can join any Python course there. See, why I switched to Python is the reason for that is because Python is open source. Okay. And my charts, I developed these charts, and I have also submitted the script in my paper which I published, but that is in MATLAB format. Like the code is in MATLAB. So but MATLAB is a proprietary, so you cannot run this without, if you don't have license. So I switched to Python because Python is a open source. You can develop your code and you can share it with people also. So that is the reason why I have developed this in Python. So I think you all can start Python. It sounds very like I don't know how Python, it is a programming language, computer science people does this, but it is not difficult, it is very easy. And I would encourage you all to learn Python. At least start learning Python at this stage. If you are in bachelor's or starting your masters, you should start learning any language, because language will help you in many ways. You will see it in later stages of your career.
Rajkiran, I have one question.
Right, sir. Right, sir.
Uh, Means after programming this formulas in the Python, so
Right,
do
sir.
you need to train your data like matlab, in not everywhere we get three sets of joint, we get more, and
Yeah, sir, we get
at places we get even two sets only, like in the cratonic areas, that is in the peninsular Indias, we generally get two sets.
right, sir.
And in the Himalayas, at places means three sets are common, four and five.
Right, sir.
In the crystalline Himalayas, that is the central crystallines, we get the third and the fourth joint also.
Right, sir.
So
Right, sir.
means the formula will change or it will continue.
Sir, actually, the formula will change. The F1, F2, and F3 formula you are talking about, sir, right?
Yes, only those formula.
Yeah. So sir, that formula will change because of the rating system. That formula will change, otherwise there is no possibility. So if you are asking me this question, that I have to develop some classification system as per my area, that can only be done if the SMR which is developed by Romana is not qualifying the my area, my study area. Even if you have number of joints more than 3, 4, or 5, sir, you can apply SMR there easily. So you will get some SMR class there.
Okay.
Functions, if I have to develop new functions for that, it means that the SMR original is not qualifying my area, so I have to modify that SMR. But right now, sir, I believe also there are possibilities that SMR can be changed. I mentioned in the beginning there are many limitations to SMR, so we can
Actually,
work on that.
actually, when I was working with the Rotang tunnel, na, so
Right, sir.
what the project authority they did, they modified the queue system and they followed a modified queue for their own purpose, suiting to their
Right,
own
sir.
thing. And for the yeah, because queue and RMR whatever was developed, it was all based on their practical experiences in the European mountains, that is the Juras
Right, sir.
and
Right, sir.
there. And our Himalayas is totally different.
Right, sir. Right, sir.
So the people, the engineers, those who were working in the Rotang tunnel, they modified it, and
Right, sir.
since with their modification, at places they failed, and that
Okay.
is why they wanted GSI to help them in means quantifying those things and putting the means quantifying it rightly and putting the support measures
Okay.
within the time.
Right,
So
sir.
the their modified system, we further modified it, and they were okay
Okay.
with that.
Yeah.
So
Right, sir. So this is actually this is always open end actually. I mentioned in the
yes,
beginning the rock mass classification systems are empirical systems and they are data
empirical
driven,
systems,
and they
exactly
are
data.
subjective. And right now people are working in to how we can make a universal system. I can see that people are working.
But there is no scope for universal system.
Yeah. Yes,
Every
sir. Yes, sir. Right, sir. This is a
because
problem with
we don't have
limitation.
homogeneous geology, that is
Right, sir.
heterogeneous.
Right, sir.
And
Right, sir.
to the young students, I would say that learn Python, That is the future.
Right, right, sir.
That
Right,
is
sir.
the
I am
future.
also, I
Every,
am also
everywhere you
encouraging.
go in an interview, they will ask, "Do you know Python?" Right? Few they will give you a chalk and go tell you to go to the blackboard, and they will say that you write a code
Right, sir.
कि आपके 10 लाइन ऐसे 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 ड्रॉ हो जाए.
Right, sir. Right, sir. Right, sir. Right, sir. They,
So
I mean, this is very future actually. This is our future.
even if you want to seek a GRF at a good reputed institution or a good reputed guide, he will
Right,
ask
sir.
you, "Do you know Python?" Then only come to me, or else don't come to me.
Right, sir. I mean, sir, foreign, if, see, this is happening in India also right
No, no,
nowadays, but
in India,
foreign.
I'm talking a latest story in India.
Okay, sir. Okay, I think, see, all the students who are here, you should be encouraged now, because sir is also saying that I was aware that in foreign institutes they definitely ask you for MATLAB or Python. MATLAB
Yes.
definitely they ask, because I have given some interviews. But in India also it has been started, and I think it is a good start, because actually we are very late, but it's a good that they are going in this
Only,
direction.
only, only the geology people are late, but our engineers, the
Oh,
engineering
yeah,
stream
sir.
students, they have learned everything in the first year or second year itself.
Right, sir. Right, sir. Right, sir.
So we are a bit late, but we should develop the things.
Yes, sir. And these, if you are working with the data science structures, like in remote sensing, there is data only. So they are working with the processing part. So I think if you are good with Python, na, so you will get a flexibility to analyze data
Yes.
immediately, efficiently. Efficiently you can do.
Efficiency. Yes, yes.
Okay,
And
so I think
even in engineering geology also, there is lot of data, and soon after some time, like 5-10 years, maybe you will develop give us a classification for the Himalayas, the RMR for Himalayas.
right, sir. Right, sir. We will work, sir. In you will also guide us, and yeah, I can see that, sir, because once you start doing research, and then you can see, you can start looking at those loops. What are the limitations of any system?
Limitation. Yeah.
Yeah, immediately start to coming to your mind. Okay, sir, thank you for your attention. And I think if you all people, if students can if you have any question to Ravi sir, you can ask regarding GSI also, like because sir has a vast experience, and you can ask any queries. Okay,
Yes,
share.
feel free to ask anything about your career and things.
uh,
I, I will try my best to guide you all.
I can see.
Uh, During my times in 2012 when I joined, the geology was picking up, means it was starting, and now it has picked up, I will say. So today it is more competitive. Earlier in the whole of the northern region, there were three institutions, three or four, I say: Punjab University, Delhi University, Jammu University, Himachal Pradesh, that Dharamshala College, and IIT. That is five institutions total. And now you have Bhatinda University, and there's some more private universities coming. So the competition and the means the mass is coming. Means when I joined geology department in year 2006, we were only 17 students. Okay, only 17 students, and the seats were total 25. Only 17 students took admission. And when we graduated, I did my master's in petroleum geology. The course was closed due to some reasons, but we were only seven students who graduated from petroleum MSc, and in the normal MSc geology, there were some around 19 or 20 students. So that time the number of people were less. This time the number of people are more, and that those people are having more exposures. Okay, so the competition is at a different level. I I think that even today also, maybe my practical experience is very much more, but there are certain subjective and theoretical experiences which I feel still it is lacking, and maybe Rajkiran or you or someone else may be knowing more than me theoretically. So there is a lot of gap between my generation, that is 2012 and 2022. So what I want to say, that the market is very competitive, and you need to develop, means you have to be one step ahead of the demand if you want to be a good geologist. GSI is all right, a very good organization. If you come, you can have a stable life, but the field part is very extensive, I will say. And there is no scope of growth after coming to GSI apart from being more practical, because you get a lot of field experiences and this thing. But there is no scope of growing. That is, you cannot go to a foreign and do
Research.
a PhD and come back and do this. Whatever you want to do at your own cost and do at your own interest. Okay. So there are some good points and there are some bad
Right.
points about GSI. Same is ONGC. At my time in year 2011, the intake in ONGC was like some 30-40 students per year, and that was through a GT examination, graduate trainee examination. That was almost like a civil service type examination. The GK was very tough. So in 2011, I cleared the written, but that time I was only a MSc student, so I could not be hired. Means I cannot appear for the interview test. So that year it went like that. In year 2012, the examination got leaked. Okay. And there was some case in Chennai High Court and something like that. There was a stay. So ONGC people, they stopped recruiting for 2 years, like 2012 and 2013 there was no recruitment, and onwards from 2014 they started taking up from gate examination. Okay. So from gate examination, all the toppers, mostly from the IITs, they started getting selected. So these university students like you all, उन लोगों के लिए अब कुछ बचा नहीं था, मतलब क्योंकि उनका एक्सपोजर नहीं था उस तरीके से, उनकी ट्रेनिंग इस तरीके से नहीं थी, और उनका प्रिपरेशन का लेवल भी उस तरीके से नहीं था. तो यूनिवर्सिटी वाले लोग रहने लग गए और आईआईटीज वाले सिलेक्ट होने लग गए. और मेरा ये कहना है कि ओएनजीसी इज अ प्लेस वेयर यू शुड बी. मीन्स पैसा, एक्सपोजर, एवरीथिंग इज देयर, एवरीथिंग इज देयर. उसके बाद फिर देयर इज अनदर पार्ट इज इंजीनियरिंग जियोलॉजी. सो इंजीनियरिंग जियोलॉजी दैट टाइम वाज, मीन्स उस समय बूम नहीं था. द बूम केम आफ्टर 2017 onwards. ठीक है. And mass recruitment started because infrastructure projects in the Himalayas and everywhere it started going on. So HJVNL, they take from gate examination, NHPC gate examination. Everyone is preferring the gate examination. So you have to prepare for gate examination. That is the key. यूपीएससी चलेगा, साथ में आप अपना जियोलॉजी का करते रहें तैयारी, कोई प्रॉब्लम नहीं है. बट अपार्ट फ्रॉम बीइंग अ जियोलॉजिस्ट यू शुड ऑल्सो एक्सप्लोर अदर अदर फील्ड्स ऑल्सो. एक एक एग्जांपल देता हूँ मैं. एक हम ही लोगों की सीनियर थी, रीचू मैडम नाम था, रीचू समथिंग समथिंग. सो शी वॉज सीनियर टू मी 1 year. शी डिड एमएससी फ्रॉम जियोलॉजी डिपार्टमेंट. उसके बाद उसने 3 साल एलएलबी किया इसी पंजाब यूनिवर्सिटी से, और सी इज नाउ अ जज इन हिमाचल. हिमाचल नहीं, हिमाचल का भी जस्टिस क्लियर किया था और हरियाणा का भी किया था. शी ज्वाइंड हरियाणा. तो आप अपने आप को ना, मतलब जियोलॉजी में ही मत कीजिए. जुडिशरी साइंसेज और ये जुडिशरी एंड अदर चीज़ों में भी जो है ना बहुत स्कोप है. तो डोंट मेक योर सेल्फ लिमिटेड टू जियोलॉजी. अगर आपने जियोलॉजी करनी है, जो कुछ भी करना है, डू इट विथ पैशन. मतलब कि आप उसका राजा बन के रहिए तो ज़्यादा
राइट
फायदा है.
सर.
नहीं तो वो नीचे वाला बन करके कोई फायदा नहीं है. तो यही सब है. तो मतलब हर 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 कुछ कर सकते हैं आप. मतलब ऐसा कुछ भी नहीं है कि आप जियोलॉजी कर लिए तो आपने ये मतलब आपको जियोलॉजी में ही रहना पड़ेगा. तो मेरे साथ क्या हुआ कि मैंने जियोलॉजी करने के बाद मैंने जियोलॉजी में ही कंटिन्यू कर दिया, क्योंकि मेरे एग्जाम्स क्लियर हो गए थे उसी समय. तो अब मेरे को लगा कि चलो अब चले जाए. बट अब रियलाइजेशन ये होता है कि नहीं, जल्दी कर दिया था सब कुछ. तो
अच्छा सर.
वो
नहीं सर, आप
करियर
कभी भी
चूज
रिसर्च तो कर ही रहे हैं.
करियर चूज करने
प्रैक्टिकली.
से पहले भी बहुत प्रैक्टिकली सोचना है.
ओके.
बहुत
राइट सर.
प्रैक्टिकली सोचना है, क्योंकि आपको लॉन्ग टर्म में उसको रिग्रेट ना फील हो कि आप जीएसआई में
राइट।
आ गए हैं तो फिर जिंदगी भर फील्ड ही करते रह जाना है, या फिर कुछ जैसे कि एक डीएई है, डिपार्टमेंट ऑफ एटॉमिक एनर्जी वाले जो हैं वो लोग 6 6 मंथ्स तक फील्ड में रहते हैं कंटिन्यूअस।
ओहो।
इनिशियल टाइम में तो अच्छा लगता है, वेरी गुड, बहुत अच्छा है। पैसे वैसे का कोई इशू नहीं होता है एक्चुअली, ये सब ऑर्गेनाइजेशन से पैसे का इशू नहीं होता है, बट इशू ये होता है ना कि मोनोटोनस हो जाता है चीजें, और आपको ग्रोथ अगर नहीं मिलेगा, नया चीज आप देखेंगे कि रिसर्चेस बहुत तरह के आ रहे हैं, बहुत नए नए चीजें आ रहे हैं, बट आपको नहीं पता है, तो आपको एक फ्रस्ट्रेशन फील होता है, यार मुझे भी आना चाहिए वो चीज, मेरा ऑर्गेनाइजेशन मुझे उस चीज में क्यों नहीं डेवलप होने दे रहा है। आपके पास स्कोप है बट आप डेवलप नहीं हो पा रहे हैं, तो वो एक लिमिटिंग फैक्टर इंडियन सिस्टम के साथ है। तो जो भी आप करें तो वो सब चीज़ों को आप ध्यान रखते हुए मतलब अपना करियर को सिलेक्ट करें। उसके बाद फिर मतलब जुडिशरी हो गया, उसके बाद फिर सिविल सर्विसेज हैं। आप हिमाचल मतलब प्रोविंशियल सिविल सर्विसेज जो है पीसीएस की तैयारी कर सकते हैं, साथ में आप आईएएस की तैयारी करिए, क्योंकि बिकॉज यूपीएससी का जो जियोलॉजी का एग्जामिनेशन है आज के डेट में, जिस तरीके का टफनेस और लेवल ऑफ पेपर है ना, डेट इज सिमिलर टू आईएएस। ठीक है, तो आप उसमें भी जरूर बैठिए, मेरा मेरा ये कहना है, क्योंकि जियोलॉजी तो आप लिख ही देंगे ये तो पता ही है, बट थोड़ा सा एप्टीट्यूड और थोड़ा सा जीके का तैयारी करना है और कुछ नहीं। तो अपने आप को जियोलॉजी में ही लिमिट नहीं रखना है, हर चीज में करना है, और जो चीज करना है उसका राजा बन के रहना है, बस डेट इज। जैसे कि अभी राजकिरण है, वो आने वाले टाइम का जो है ना, फ्यूचर का इंजीनियरिंग जियोलॉजी का राजा
अरे
है।
कहाँ सर, अभी तो सीखने को है बहुत।
नहीं नहीं नहीं, अभी मतलब जो लेवल मैं देख रहा हूँ ना आप लोगों का, तो वो उस लेवल से आप लोग अपने सिस्टम अपने टाइम से थोड़ा सा अहेड चल रहे हैं, तो आप लोग भी कोशिश कीजिए, बाद बाकी जो यंगस्टर्स हैं इसी तरीके के पैशन को परसू कीजिए और आगे बढ़िए उसी
राइट
तरीके
सर।
से। मतलब एमएससी करने के बाद जरूरी नहीं है कि आप जॉब की तरफ जाएं, एमएससी करने के बाद कॉमनवेल्थ फेलोशिप के लिए ट्राई कीजिए, और जा करके इंपीरियल कॉलेज से एक और एमएससी कीजिए, इन इंजीनियरिंग जियोलॉजी करना है या फिर एमएससी इन पेट्रोलियम जियोसाइंस करना है, या किसी भी चीज़ में कीजिए। और ये एक हमारी मैडम होती थी, एक और सीनियर थी, वो शायद 2 साल सीनियर थी, एकता नाम था ना, समथिंग कुछ, एकता भाटी। डैट मैडम वेंट टू सम, वो भी यूके गई, शी डिड 1 ईयर एमबीए, और उसके बाद वो गूगल के लिए काम करती है। जब भी मैं उनसे मेरा बात होता है ना, तो आज रवि मैं ब्राजील में हूँ, तो आज मैं अर्जेंटीना में हूँ, तो आज मैं यूएसए में हूँ। तो मतलब एवरी मंथ उनका 3 4 टूर 3 कॉन्टिनेंट्स में लगा ही रहता है। तो ऐसे भी जियोलॉजिस्ट हैं हमारे डिपार्टमेंट के, कि जो लोग ने अपने आप को लिमिट नहीं रखा और वो लोग आगे निकल गए। कोशिश
राइट सर।
कीजिए कि आप लोग एक डिग्री, एटलीस्ट 1 डिग्री फॉरेन से निकाल लें। फेलोशिप बहुत है, और फेलोशिप के ऊपर जो है ना आजकल, तो मतलब मैंने एप्स और एप्स देखे, कितने सारे लोग मतलब इंडियन लोगों ने स्टार्टअप्स कर दिया है कि फेलोशिप दिलाने और वो सब खोजने और ये सब करने में, बहुत फेलोशिप्स हैं। आप लोग
आई
उसको
थिंक
ट्राई
सर
कीजिए।
बेसिकली लिंक्डइन पे भी अगर बच्चे ज्वाइन कर ले तो वो आई थिंक बहुत
लिंक्डइन पे
काफी आपको
बिल्कुल,
दिखा देता है चीजें।
बहुत 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 स्कोप है लिंक्डइन पे। आप ज्वाइन करके अच्छे अच्छे लोगों को ढूंढे, अच्छे फेलोशिप्स ढूंढे,
ढूंढ सकते हैं।
आराम से आप बाहर निकलिए, और एटलीस्ट मेरा कहना है कि 1 ईयर आप एक कोर्स आप बाहर से करें, तो आप लोगों का फ्यूचर अच्छा मतलब डिफरेंट होगा, टोटली डिफरेंट होगा। साउथ
राइट
इंडियंस
सर।
जो है ना, मतलब साउथ इंडियन जियोलॉजी स्टूडेंट्स जो हैं, उनका यही आज के डेट में रहता। उस टाइम पे 2012 के टाइम पे तो था कि जीएसआई करना है। आज के डेट में उनका अगर पैशन, अगर आप हम मैंने कई लोगों से बात किया, वहाँ के केरला के स्टूडेंट से, कर्नाटका और ये सब से, तो उन लोगों का पता क्या है कि दे वांट कि आफ्टर डूइंग एमएससी दे विल गो फॉर अ पीएचडी और सम स्मॉल कोर्स और रिलेटेड टू जियोलॉजी और नॉट रिलेटेड टू जियोलॉजी, एंड डू इट फ्रॉम फॉरेन ऑन गवर्नमेंट फेलोशिप, और लाइफ उसके बाद डिफरेंट हो जाता है टोटली। तो आप इस तरीके से भी अपने आप को ये कीजिए, मार्क्स लाइए, अच्छे ग्रेड्स लाइए, अपने 90% 80% जितना भी स्कोर करना है करिए, लेकिन बैक ऑफ द माइंड अपना करियर को खुद ही प्लान कीजिए कि मैंने क्या करना है। पाइथन तो आंख
आई
बंद करके
थिंक
पहले सीख लो।
ये देर आर स्टूडेंट्स ऑल्सो। तुषार, आपको कुछ पूछना है? आई थिंक यू हैव क्वेश्चंस, तुषार।
तो यस सर, नमस्ते सर।
हाँ तुषार, तुषार नमस्ते। तुषार बताइए, आपको कोई क्वेश्चन है? अगर आप सर से भी पूछ सकते हैं, मेरे से भी पूछ सकते हैं, अगर आपको डाउट्स हैं तो।
सर वैसे उतना कोई क्वेश्चन तो अभी मन दिमाग में आ नहीं रहा था। बस एक बार एक मेरे सीनियर ने पूछा था, दूसरे ब्रांच से सीनियर ने, कि आप जियोलॉजिस्ट लोग अगर इंडिविजुअली कुछ करना चाहो तो आप क्या कर सकते हो इंडिविजुअल लेवल पे, ताकि
बिल्कुल
आपकी अर्निंग भी हो कुछ और आप
बिल्कुल
कुछ
बिल्कुल मैं उसका आंसर देता हूँ। उसको जाके बोलना ना कि एक
सर
रितेश आर्या
दीजिए।
नाम का बंदा है,
जी सर।
ठीक है, जीएसआई का जियोलॉजी का ही स्टूडेंट है, अशोक साहनी का, वहां पे पीएचडी स्क्रॉल में नाम भी लिखा होगा, रितेश आर्या। बंदे का खुद का ड्रिलिंग कंपनी है, कसौली के रहने वाले हैं, एंड ही होल्ड्स अराउंड सम 3/4 वर्ल्ड रिकॉर्ड हाईएस्ट ड्रिलिंग के। उनका वो जहाँ पे ड्रिल करते हैं वहां तो पानी निकलना ही निकलना होता है, और उनका वर्किंग का स्टाइल क्या है पता है? नो वाटर नो मनी। मतलब किसी से अगर ठेका लिया कि आज मैं यहाँ पे एक ड्रिलिंग करके आपको एक पानी दूंगा, तो ड्रिल करेंगे, पानी अगर मिला तो पैसे लेंगे, नहीं मिला तो ड्रिल, मतलब जब तक नहीं मिल जाता तब तक तो नहीं लेते हैं, और नहीं, और बिल्कुल ही उनको पता लग गया कि नहीं मिल सकता, स्टार्टअप वो सब ड्राई है और ऐसे है वैसे है, तो वो एक पैसा चार्ज नहीं करते हैं। एंड ही इज अ एग्जाम्पल ऑफ इंटरप्रेन्योरशिप। मतलब मैं बोलूँगा पता है किस साल से, वो 98 2004 वाला जो ईयर जो था ना, वो वाजपेयी गवर्नमेंट वाला टाइम, उस टाइम के इंटरप्रेन्योर हैं वो लोग।
राइट
और
सर।
आज आज वो लोग ना आर्मी को पानी सप्लाई करवाते हैं, सियाचिन में जहाँ ड्रिल कर देते हैं वहां से गर्म पानी निकलता है। सियाचिन में आर्मी जो है ना उनका गर्म पानी यूज करता है। तो उनको
राइट सर,
बोलना।
हाँ ये उनका वर्ल्ड रिकॉर्ड भी है सर, बिल्कुल सर, उनको मिलते रहते हैं हमें।
तो
कई बार
ये
व्यू
तो
आते हैं।
मैंने एक सिंपल सा एग्जांपल दिया। कई सारे हमारे सीनियर्स भी हैं और कई सारे जियोलॉजी के स्टूडेंट्स हैं, कि इतने सारे आज के डेट में कंसल्टेंसी है, जियोलॉजिकल कंसल्टेंसी, क्या कुछ भी नहीं सकते हैं।
राइट
कमिंग
सर।
एरा जो है ड्रोन का है, ठीक है, पाइथन प्रोग्रामिंग कर दीजिए, अपने कैमरास को, अपने जीपीएस को प्रोग्राम कीजिए पाइथन से, ड्रोन उड़ाइए, वो आप बैठे बैठे घर में ड्रोन को छोड़ दिया, वो जा करके सारा मैपिंग करके आ जाएगा। ऐसा टाइम आने
राइट
वाला है।
सर।
तो
बिल्कुल सर, बिल्कुल।
मतलब ड्रोन्स में चल रहे हैं, ड्रोन ड्रोन पायलट तो आजकल मैनुअली लाइसेंसेस ले रहे हैं, ये ले रहे हैं, लेकिन बहुत जल्दी जो होगा इतने सेंसर्स डेवलप हो जाएंगे और सस्ते हो जाएंगे कि मतलब सब प्रोग्रामिंग बेस्ड हो जाएगा। तो आपको जियोलॉजी आती है, कोडर को कोडिंग करने आता है, तो इन दोनों के बीच का गैप आपको ही खत्म करना होगा। तो इसीलिए मेरा ये कहना है कि आप लोगों को पाइथन या फिर और दूसरे कोडिंग्स सीखना चाहिए। और
राइट
और
सर।
ह्यूज स्कोप है, ह्यूज स्कोप।
हाँ ये तो है सर, बिल्कुल। जैसे सर ने कहा कि बहुत सारा स्कोप है, तुषार आप इंडिविजुअल लेवल पे कंसल्टेंसी कर सकते हैं। और जैसे सर ने बताया वो ड्रोन का और पाइथन का आजकल बहुत हो रहा है, तो आई थिंक यू शुड स्टार्ट लर्निंग, और ये सब चीज़ें आप कर सकते हैं मतलब। ठीक है, और किसी के कोई क्वेश्चंस हैं अगर? आरती शर्मा, यू आर फ्रॉम बीएससी और एमएससी, इफ यू
हाँ,
कैन हियर मी।
इवन इवन कोई गर्ल्स अगर हैं, उनका उनके लिए कोई क्वेश्चन चाहिए तो उनको मैं बताता हूँ कि एक एक अपना ही सीनियर है, सीनियर नहीं है, मतलब अपना ही जूनियर है, ठीक है। तो उसने कुछ नहीं किया, सिंपली एक कंपनी को रजिस्टर किया, ठीक है, और वो रिमोट सेंसिंग एंड जीआईएस से के फील्ड से रिलेटेड कंसल्टेंसी देता है, मतलब मैप्स बनाता है, ठीक है। ओपन सोर्स है आपका क्यू जीआईएस, उसके बेस पे वो, उसको पाइथन भी आता है, तो उसने कोई कई कोड्स भी डेवलप कर दिए और ये सब। तो आराम से बैठे बैठे जो है वो अच्छे खासे मैप्स बनाना, ये करना वो करना, और उसका डेली का इनकम 4,000 रुपये है, ठीक है। तो हमेशा गवर्नमेंट के पोर्टल पे जो है ठेके निकलते रहते हैं, बस खाली ऑनलाइन अप्लाई करना होता है, सब कुछ ऑनलाइन प्रोसेस होता है, और उसके बाद फिर ये, तो इवन आप लोग 10 लोग मिल करके जो है ना एक कंपनी खोल करके आराम से जीआईएस रिमोट सेंसिंग का बैठ करके मैप बना सकते हैं। अब तो पूरा स्मार्ट सिटी बनने जा रहा है, तो स्मार्ट सिटी से पहले जो है ना प्लानिंग के लिए बहुत सारे मैप्स की रिक्वायरमेंट होती है। नहीं तो पता लगा कि ड्रेन जो है इतने लेवल पे रखना था, किसी ने ऊपर रख दिया, तो सबके घरों में पानी आ गया।
राइट सर।
तो इस तरीके का सिचुएशन मैं यहाँ पे देखता हूँ ना, झारखंड रांची में स्मार्ट सिटी में हर साल थर्ड आता है। तो
अच्छा सर। पर
मैं यही
पानी।
सोचता मैं यही सोचता हूँ किस बेवकूफ ने इसका इंस्पेक्शन करके इसको थर्ड दिया है। और
चलो।
हमारा चंडीगढ़ जो कि मतलब कितना एडवांस है, फिर भी वो कुछ नहीं कर पाता है।
हम्म।
तो ये लोग उसी रास्ते में ले जाके दिखाते हैं जहाँ पे इनका सबसे बेस्ट है, बाद बाकी एरिया को छोड़ देते हैं तो सारा मतलब डूबा हुआ रहता है। तो
ओ।
प्लानिंग बहुत प्रॉब्लम है, और प्लानिंग उसी समय हो सकता है जब आपके पास अच्छे नक्शे हों, अच्छा जियोलॉजिकल
राइट सर।
नक्शा, मेथोलॉजिकल नक्शा, लैंड यूज लैंड कवर नक्शा। और नक्शा कौन बना सकता है? जिसके दिमाग में वो सारी चीजें हों, जो लैंडफॉर्म्स को स्टडी कर सके, वो आप लोग हैं। तो यही है।
थैंक यू सर। ये काफ़ी इंपॉर्टेंट पॉइंट्स आपने बताया। आई थिंक काफ़ी डाउट्स क्लियर हो गए होंगे बच्चों के। अगर बाकी हैं तो हम चेस्कॉन आ रही है, मैं तो ये बोलूँगा सबको चेस्कॉन में पार्टिसिपेट करो। अक्षय, बाकियों को भी बता दो, और जितना हो सके चेस्कॉन में करने से थोड़ा काफ़ी आपको ना वो एक्सपीरियंस भी मिलता है प्रेजेंट करने का। काफ़ी सारे स्किल्स आपके धीरे धीरे डेवलप होने शुरू हो जाएंगे फिर, ठीक है। तो ये एक मैं एडवाइस दूंगा, चेस्कॉन में स्टार्ट करो प्रेजेंट करना, राइट। तो आई थिंक मेरी तरफ से आज का हो गया है। थैंक यू। थैंक यू। हाँ, थैंक यू अक्षय। थैंक यू रवि सर ऑल्सो फॉर ज्वाइनिंग। ओके।